Hello, class. It's Mr. Mormon. Welcome to Nature of Science Lesson 7, the metric system. Today, we're just going to do a basic introduction or overview of the metric system. Now, when scientists make observations, it is not sufficient to say that something is just big or heavy. Instead, scientists use instruments to measure just how big or heavy an object is. By measuring, scientists can express their observations more precisely and communicate more information about what they observe. The standard system of measurement used by scientists around the world is known as the International System of Units, which is abbreviated as SI. In French, it's Système International. That's where the SI comes from. SI units are easy to use because they're based on multiples of 10. Each unit is 10 times larger than the next smallest unit and 1/10 the size of the next largest unit. The metric system is the unit used in most countries around the world. And all scientists, no matter where they're working, use the metric system. And as we've already said, it's based on units of 10. You're going to see in a minute what that means when we look at the prefixes. The base units used in the metric system are the meter for length, the liter for volume, and the gram for mass. The base units represent 1. We can add prefixes to the base unit to represent either multiples of 10 or smaller units, tenths or hundreds or thousands. And here's a chart that explains that a little better. Kilo means 1,000, hecto 100, deca 10, deci 1/10, centi 1/100th, and milli is 1/1000th. You can see the symbols there as well. You add these prefixes to the base words and you get the new unit. For example, 1,000 meters would be equal to 1 kilometer or kilometer. Now I've added the base unit in the middle of this table to better understand how this works. So meter, liter, gram, those represent 1, and that's the base unit. You add the prefixes to the base unit to get the different either larger or smaller units. For example, a millimeter is 1/1000th of a meter. Now, there is a way to help remember these prefixes in order. It's a silly little sentence that I've heard students use before. King Henry died by drinking chocolate milk. The K can remind you of kilo, the H for hecto, the D for deca, B for base, D for deci, centi, and milli. The next thing I want to talk about is scientific notation. Scientific notation is often used in science to represent either very large or very small numbers, which our measurements are very often come out that way. The way scientific notation works is very large or small numbers are expressed as a decimal, a number between 0 and 10 that is then multiplied by 10 to a power. It's easiest to understand this by doing a couple of examples. So if we started with a distance of 12,000 kilometers and wanted to express this in scientific notation, what we would need to do is move the decimal point back between the 1 and the 2. I then have a decimal between 0 and 10, and now I'm going to multiply it by 10 to a power. And because I moved the decimal point 4 places to the left, that would be 10 to the 4th. All right, so 12,000 kilometers is the same as 1.2 times 10 to the 4th. Now let's try one using a very small measurement. Okay, here we have 0.000013 meters. I mean, sorry, that was 0.0000 0.013 meters. And I want to turn this into scientific notation. Again, I need to move the decimal point to get me my decimal between 1 and 10. So that would be 1.3. And this time I moved the decimal point the other way. I was going to the right. So those are going to be negative exponents, and it would be to the negative 5, or to the negative fifth power. So it would be 1.3 times 10 to the negative fifth meters. Okay, next I'd like to talk about some tips when using the metric system. My first tip, and probably the most important one, is when you record a measurement, you always have to include a unit. Next tip, measure to the tenths place whenever you can. When using a metric ruler, you can measure to a tenth of a centimeter. When using a triple beam balance, you can measure to a tenth of a gram. Make sure you use the metric side of the ruler. That's the side that has centimeters on it, and always start at 0 on the scale. I'm going to show you what I mean. So always remember to use the metric, the centimeter side of the ruler, and start at 0. Here in this example, I put a pencil up against the ruler, and you can see that the scale here starts a little bit in from the edge of the ruler. You do not put the pencil to the edge of the ruler. You put it at the 0 on the scale, and then you go to the other end to read the length. And in this case, this looks to me, if I was to record this, I see 9. This looks to be about 19 points. Well, I see 0.5 would be the longer one, right between 19 and 20. And it looks like it's maybe 19.3 centimeters. That's how I would record my answer. Notice that I wrote the units. Here, now why don't you try this one? I've lined up the pencil so that we can measure the width of the pencil. What would your answer be? Looks to me maybe 0.7 centimeters, I think would be a good answer. Of course, that would be the same as 7 millimeters. Okay, next tip. Whenever you need to do some math with your measurements, a lot of times we use formulas and we have to do calculations, or maybe you're averaging a group of numbers. Make sure that you round your final answer to the same precision as your measurements. Again, that's usually going to be to the tenths place. Now, if you make a measurement and it falls exactly on a whole number, make sure that you record those to the tenths place as well. This shows the accuracy that you measured to. And here's what I mean by that. Here's a pen that I put up against the ruler. Notice I've lined it up perfectly at the 0 line here. And when we go to the other end, it looks like it's almost exactly 15 centimeters. And I would record this as 15.0 centimeters. Now, I know that mathematically 15.0 is the same as 15 centimeters, that they're equal lengths. However, when I write my answer to the tenths place like this, it shows me the accuracy that I measured to. It shows me that I can tell the difference between 14.9, 15.0, and 15.1. When I write it like this, it's telling me what you're saying is you don't have the same accuracy. That, you can't tell the difference between 14.7, 15.2, 15.1. You'd round them all to 15 centimeters. So make sure you're writing your answers to the precision that you're measuring to. And even if it's to a whole number, write it 0.0. Okay, the last thing I want to talk about is doing conversions, converting SI units. This is really pretty easy once you understand that everything is going by tens. It's just really a matter of multiplying and dividing by tens or multiples of 10. And really what's all that's happening is the decimal point ends up moving. But let me show you a good method so that you can do any kind of conversions in the metric system. So here's my method. Okay, you start by writing down the measurement you want to convert. You're then going to write a conversion factor that represents the relationship between the two units you are converting, the old unit and the new unit that you want. This is going to look like a fraction where the old unit will be in the denominator and the new unit will be in the numerator. You will then multiply through by this fraction, this conversion factor, and the old unit is going to cancel out, leaving you with new units, a new value with new units. And here's what this looks like. So in this example, I'm starting with 80 centimeters, and I want to change it to meters. So here's the conversion factor that you would put in. There's 100 centimeters in a meter. I put the old unit in the denominator so that it cancels out. We can see that it cancels out when we multiply through. Of course, this is over 1, right? So now I just need to multiply through. I've got 80 meters over 100. And when I divide 80 by 100, I get 0.8 meters. All right, and there's my answer. So 80 centimeters equals 0.8 meters. So let's try these other ones. 600 millimeters. I'm going to use the abbreviation mm. How many meters is that? All right, well, we need to come up with a conversion factor. So we're going to take 600 millimeters. We're going to multiply by a fraction. Now I want millimeters on the bottom, and meters are going to be on the top. Now I know in 1 meter, going back to that table we were looking at before, there's 1,000 millimeters. All right, so again, my millimeters are going to cancel out. I get 600 over 1,000. And my final answer is going to be 0.6 meters. Okay, you try to do the next two on your own. Pause the video for a minute, try them, and then check the answers. Okay, here's the answer to number 2. Let's just finish this one up. Here's the conversion factor I came up with. I want to change liters to milliliters. So again, my old unit goes in the denominator. So the liters are going to cancel out here. There's 1,000 milliliters in a liter. And when I multiply through, I get 300. The answer is going to be 350. 0.35 times 1,000, multiplying by 1,000. My decimal point is just going to move over 3 places, so it's 350 milliliters is my final answer. Okay, and the last one, I'm changing grams to kilograms. My conversion factor, I'm going to have grams on the bottom. Kilograms on the top. So 1 kilogram is 1,000 grams. So that's going to cancel out. I get 1,050 kg over 1,000. And my final answer is going to be 1.05 kilograms. I always like to circle my answers. Okay, that's it for today. I hope you got these examples right, and now you know how to do any kind of conversion in the metric system. Just use the same method. We'll see you tomorrow in class.